Okay, so let's implement the negation. So yeah, I think that would be a good next step. I think it should be pretty easy, and it will allow us to understand how to do the binary operations, because it's like a binary operation but easier. So, it should be called. Hmm, I guess we already have here the method name. So assign neg, but yeah, it should take like the same arguments as all of them, maybe except the instruction. It should be assign unary, and we don't need that because we know it's gonna be negation. So let's go to this method and obviously just copy it because yeah, and let's say neg. So it's gonna be this one, but we need to provide here assign unary. So yeah, make it like this. Okay, so um, as I guess other um, expression or instructions from cool language, it needs to generate a new object on the return type, right? So we're gonna create a variable. So let's say t0 is gonna be a new int, right? And I have this helper method which just creates a new object. So if you saw that part with main, it creates the prototype object, then it copies it and calls init on that object. So it's gonna be a copy inside of the heap of the prototype, right? So yeah, should be just like that. But here we are gonna do an int, right? We do an int. Then we have to probably load the value of the integer into a register to be able to negate it. Now that I'm thinking it, this one should be similar to not actually, because it's like not but for numbers instead of boolean. But I mean, it's fine. So we need to take the expression, we load a variable, and again I have this helper method which just loads a variable from the stack into a register. Then we have to load the attribute. So this one, yeah, this one takes the the attribute, but I forgot there to specify that it actually takes it from you need, yeah, I don't know why I really like this though. Let me see. Because I'm not really sure why we need like we need identifier to specify that thing, but it takes the attributes from the first register, so it's yeah, I mean, you need to call load variable first before you can get the attribute. So yeah, I don't know. Anyway, let's see. So we take the first one, and I think we can keep it in rocks, right? So then what we have to do is to flip it. So yeah, do like minus t0. So let's get rid of that. Keep this, and here we have to do basically t0 Right, should be maybe ident. Okay, so let's see, is there really a neg instruction? Negates the value, but is it really? Let's see. The 2's complement, yeah. Multiply by -1, okay. So we can do, okay, that should be nice. So this negates the register, and then we want to set the the attribute to RAX. So let's see, this one, so this one loads the variable, okay. Then it's pretty strange that this one doesn't load the variable. I should, maybe I should do that. Like load the variable in this one as well. I think. Like load the variable and then get the value. Here is set and there should be get. Because what if you forget to, I guess let's see where this function is called. So like then it would mean that we don't need this one, right? Like we just say, okay, get the boolean value of this thing into rocks, and it also makes sense with the description of the function. Like here we wouldn't need this, yeah. Here we wouldn't need this one. This one too. Then again here, because it's just getting it through this function. So I think that would work. Maybe here. Also this one. Okay, yeah, this is the knot I was talking about. So for knot, what I'm doing is just XORing this. So yeah. So basically it's like two not T0, let's say. So now it looks the same as this one. But yeah, we have to specify that okay, T0 dot value. We have to specify that it's like the value itself, not the variable. Okay. And Oh, it's T1. Okay. Okay, so now we should have neg, right? But let's check that. Let's check that thing still works. So let's make and build one. Something is not working. But I think might have changed something here. No, it shouldn't be changed. Okay, this is a bit strange. Yeah, it's really weird because hmm, but why is it only for the boolean? So it's for less than equal. Maybe I forgot something there. Not really sure. So we get the attribute of left hand side. I mean, let's just copy paste less than into less than equal, and let's change this to set LE because that's the only difference between them. So yeah, like if we do 4, it's hello world. But it's always hello world. Yeah, something's broken here for some reason. It, okay, let's see. So start I. Let's mhm. Let's take the address of this thing and continue to it. So this thing I think is the one that reads the number. So let's say 3. What's this function called? I think it's length. So we can skip it. But yeah, we should see. Oh, it's I was checking for length. Okay, then it should be fine, I think, because if we do something like this, hmm, excuse me, what? Okay, let's still look at GDB because I'm curious why it's like that. Okay, I mean, we need this as a breakpoint. Continue to it. Continue. Okay, and here let's do something like so. It should say input is less than equal to 4. So if we do something like ABC is gonna be, or AB is gonna be less than equal to 4, right? I don't. Okay, let's restart it. So we want to go here, breakpoint, continue, and let's go. Let's this one I said it reads the number or whatever it is there. So ABC. This should be the length function. So if we skip it, we should see 4 in the, or like this is an int, right? So it's an int. So we can check the value from here. We can examine like 32 hex. Um, yeah, I mean I have no idea why it's like this here. 03. I mean 03 is I guess for ints if I remember correctly. So int tag. Okay, let's see. Int tag is the first one. So it should be 2, 3, 4. So it's not. Yeah, I don't know what that function was, I guess. Because now we have two function calls one after the other, so like what? Meets hello, yeah. I have no idea. Like it doesn't really look. What was this function? Mm-hmm. So maybe there's something wrong in the read. No idea. Okay, let's go in the read and see. But yeah, let's. Damn, I actually got it. It was because I forgot to multiply. I mean, you can imagine that this was really painful, but here I have this size of function which calculates the size of an object, and I like it was obvious that okay, I have to get the like the size attribute that's on an object, right, and just return it. It should be pretty easy, but I actually forgot to multiply it by 8 because we have 8 bytes, right? So damn, that was anyway. So now it works. It says that correctly, and if it's longer than 4, it's another message. So now it's fine. Okay, yeah, let's go back to the negation. So now it should be fine. Right. So if we go in hello.cl, I have no idea how to check that, but let's do like this will always be false. So if I try to do something, it should show hello world. Yeah, but we actually need some math operations to be able to use that, actually use that, right? So let's delete that to do, and let's do the add and the other ones, right? So it's gonna be similar to this, but it's gonna be here assign add. Let's copy this one is copy pastable like this, and now let's go to our definitions, take this one because it's similar, copy paste it to the add, and yeah, now we need the int, right? We need the first the result basically. We need to take the first argument, like take the first int value, take the second one into rocks, and I guess it should be pretty easy. We should add rocks and RDI, and set the T0 value, and this one should be int here. So my guess is this should be enough for doing the add. If we go back in here and say something like +1, now if we do something which has length of 4, it should say hello world. Oh, did I forget to recompile it? Yeah. So if it has length 4, it's gonna be 5 after that, so yeah. And if it is only 3 or only 1, it's gonna be less than 4. So now we have additions. Let's copy paste this one. I'm curious to see how we're gonna implement multiplication and division. That's always because sub is gonna be just sub, and now we should have like minus. So let's say we do -10 and check if it's smaller than -4. So if we do some, if we do an input, oh, I haven't called that one. So we should, I guess, take this thing, put it here, and call to sub So if we run it, if we do a really small input, it should be true. Wait, should it? Like 1 minus 10. I think it should be true. And if we do a really large input, okay, let's do int because this is becoming annoying. Int. So if we do 1 minus, but yeah, 1 minus 10 is smaller than negative 4. Okay, how about 10 minus 1? Oh, 10 minus 10. And I guess if we do 6, that should be equal. So 7. Is it really sub-instruction assembly? Is it there like a separate instruction for doing signed? Oh my god. Like, I have no idea why integer. Yeah, interesting. Like, I guess add clearly works. So if we do plus 10 and it's smaller than 14, it was working. So if we do 1, it is smaller. And if we do 100, it's greater. So those are fine, but add B. Yeah, anyway, I guess this would be a step to check with GDB because I clearly don't know if okay, let GDB this. Okay, this should get us into main, right? So now we are in main. This is reading the number from stdin. So let's just skip it. So let's do something like 4 to make it negative. Okay, so let's see. This creates the boolean object. We can skip that, we don't care about it. And yeah, now let's see. Or is it? I think that created the integer object because we are doing some math operations. Yeah, I mean, we'll see. Here we move into RTI 4, which is the first number. Then we take into rocks the second number, which is 10, and we subtract from uh-huh. I did it in the wrong order for subtract. Okay, I mean, yeah, so for this one it doesn't matter because it's like add is, mirrored, but for subtract we have to do, like when we subtract, the first operand is in RDI, so we should do RDI rocks, but then so maybe prepare a breakpoint like here. So if we rerun this thing, hopefully there is a breakpoint. So start right. So if we input 4 again, we should see that we have 4 in RDI and 10 in rocks. But when we wait, why is it the same subtract? If we do 4, it subtracts its, yeah, like that. Okay, so this means that now it should work probably. But we have to, we need this extra move, which is a bit annoying. Yeah, anyway. So I guess this should fix that. So if we do 4, it's gonna be less than because it's negative. But if we do 100, it's gonna be positive. Okay. And I guess 6 would be the limit. So let's also test case the limit, like 7. 7 minus 10 is minus 3. So something's wrong there. Like 8 is still negative. 10. Wait, that's not true. 12. Okay, now let's go back to the GTB. So let's continue to that. So if we do 7, I was interested, I guess. So here we get minus 3. I think that's minus 3. At least that's what I would say. Then we have some call that I have no idea what that call is for. Is this entire thing like just copying stuff? Okay, so we put that there. But why was it 0? But is this creating a new integer, I guess? So I can continue. Right. So we have 0. Wait, why is it 0? In racks. So for neg, we create a new integer. Oh, here I should have done expression. Yeah. Okay, so now if we do 7, it should be greater than, and 6 is the limit. So it's -4 is smaller or equal than -4. So yeah. Yeah, I forgot here. Yeah, should have used expression. Anyway. So now everything should be fine. And let's go ahead and try to do multiplication. So let's take this thing. Let's go here and let's do multiplication. So I guess multiplication is a bit different because okay, it's here. So it multiplies content of store the result. I mean, I guess can we use 3 operators like that? I mean, it would be nice for this thing. You can, but I mean, I'm not gonna do that. So, yeah, for multiplication, not sure if it's enough to just do mul. But let's say we multiply the int by 10 and check if it's smaller than 40. It's like so from what I remember, looks like mul only takes in a single argument or something. Mul instruction. Okay, so it multiplies x, so we have to specify only RBI, for example. If we do this thing and say something like 3 is smaller than 4, and if we do 6 is larger than 4. Okay, looks easy to me. Let's see division, how easy it is. Active div should be similar, but like it will only take a single register, I guess. That's why I think it's similar, but I don't remember which registers that is. So let's see div. So div, it's So we get both the okay. Okay, I see. So it splits the A register into two. Like the high half is gonna be the division. Oh, EDX, EAX. Mhm. So let's see, maybe this thing right here it's a bit better. Like I just need an example to see. Okay, so if the dividend RTX RAX, the quotient will be in this one, and the remainder in RDX. So I guess we should make RDX 0, then use RA. Okay, let's see. Let's say this is division, this is multiplication. So we might need to XOR RDX, like for this part. We have stuff in our AX and we want to divide with RDI. So we are gonna get the quotient in REX. So that should work. So if we divide this by 10, let's say 4, okay, and we try to recompile the thing and run it. So if we do 30, it should be smaller than, yeah. And if we do 100, it should be, damn it, it should be larger. Mm-hmm. Okay, interesting because I did it exactly like here. Like, or should we have the number in RDX? So let's do this and let's move the number in RDX. Let's try that. So if we do 30, it's whoa. Okay, what? Excuse me, what the hell? Oh, I think, yeah. So RDI has the first number, the number that we want to divide, and REX has the second one. So I think for this one it would be easier to say something like this. So we take the second number first, then we take the first number, we XOR RDX with RDX, and then we divide. So 30 should be smaller and 100 should be larger. Okay, perfect. So I guess this idea should also work for sub. So we take this one, move it here, and now we should be able to subtract them. So if we do, let's say, minus 4. So if we do, for example, 40 is gonna be less than, and even 70 is gonna be less than, and 80 should be still less than equal, and 90 should be Interesting. 90 should be larger. That's weird. Now we take right hand side, left hand side. Oh, we sub it. So let's see. So if we do 70, I said it's gonna be smaller, but 90 is gonna be larger. Okay, and 80 is still small. Okay, perfect. So yeah, I guess now all these operators work. But yeah, we still don't do variables. Like I have that to do statement. So here we still don't look for the variables from let statements or function calls. I guess let statement should work. Not sure about it though. Let's see. Let x is equal to int in. I don't remember exactly how it looks like. So if we do x here, let's make it 4. Oh, it's like this without that thing. Yeah, because it will look for the name x. But I mean, yeah, let's first. Okay, so just want to do this thing. Wait, what was? I mean, it's the object size, right? It's size of. Okay, anyway. So after that we did math operators, okay, and I guess assembler. Yeah, like would be interesting to do the load operators because yeah, they're gonna be useful. Where was it? Here. So here we look only through the locals, right? We know the current class. But I guess we don't know the current method though. Like to search for or yeah, like when we do let statement. Okay, let's check in code gen. Or actually, let's do something else a bit better. Let's generate the code gen, so the tag for hello. So let's see how it looks like. So here we Okay, this is the hello thing. So here we say t0 is equal to this guy, and then x is equal to t0, and here we reference to x. Okay, so that means we need what? Like a mapping for assignments, right? Okay, let's do something even more difficult. So let's go into hello, and let's put here, let's have like show message. Maybe here also show message just to make it more interesting. And if we check again the, whoa, what? Yeah, copilot doesn't know that you cannot use that. Okay, so now show message also takes in an argument, right? But the argument comes from the arguments. Like this variable comes from the arguments. So we need to know the current method to be able to use this. Right, like when we want to load a variable, we might need to also know the current method. We know the current class, or I guess that's what I think class index is. So this one takes in class index. This one also takes in class index. This guy takes in class index. Also this one takes in class index. That's interesting. Even attribute init takes in class index. Also takes in attribute index, but that's not really needed. This takes in class index and object init. So yeah, the index comes from the objects init. Here for method, we also take in method index, so that would be useful to pass in here. But that would make them a bit different. So maybe method index will be like -1 or something, so you can differentiate. I don't know. And for methods, yeah, the index comes from here. So implementations, yeah, right. Am I right though? Because I don't think that's the class index. I think I is just the index here, but it's not really the class index. Yeah, that's not the class index though. Only for object init is the class index. Okay, I guess, yeah. Like for this, oh, it's method index, yeah, yeah. So when I call, wait, where is it? Okay, I pass in I, but it's method index. Yeah, it's method index. And here I guess I compute the class index, yeah, with j. As I said, we might need a method index for that thing. Because, yeah, like we are in here and have no idea about the context. So I guess another idea would be to have here some stuff about context. For example, an size t pointer current class, if there is one, a size t pointer for current method, something like this. And now when we do emit method, we can actually say something like context maybe it's gonna be like a pointer to this thing just for the memes. Yeah, so I guess I can do something like context current method is gonna be method index. But yeah, see, like if I do pointer, uh, because I would do pointer just because but at the same time it can also be like this. Right, but maybe having the index is better. I don't know. Because yeah, it would also make sense to have the pointer straight up. Because you would have it as null or as this thing. And from here, do we really need, like what do we need? We have the method node. So that's, I guess, enough. Yeah, let's try this. So let's do something like this. And let's say this is equal to method. And I would also say that at the end, we should reset it to null. Or maybe it would make more sense to put it here and here just to make it obvious what it goes on there. Maybe something like this. And I guess for the class, we can do the same thing. Current, no, context, current class. Should be parent mapping item, but parent mapping item doesn't really have anything interesting. I would need more like this thing, like the attributes, class mapping. So this one is the class mapping. So this should be class mapping. Class mapping item, I guess. Where the hell is it? Yeah, class mapping item. Does it have a name? It's class name. Okay. So here should also be classes items. So I would take the class like this to have a class mapping item. So we have this thing. Current class is equal to yeah, like that. That could also work. Maybe having the names, but that's a bit useless, to be fair. So let's actually just class. Let's actually just remove J, like class index from this thing. I don't think it's gonna be needed. I don't think it's gonna be needed. Right. And here at the end we can make the current class as null. So this should work. And where is now the attribute? Because the attribute is gonna complain. So let's say context current class is equal to class. Maybe current method should be set explicitly to null in here, just in case, like we never know. So this one wants the current class, but it won't get it. So yeah. So here I would put it like this maybe. And yeah, as I said, I don't think we need the current we might see that we don't even need even more stuff. Like I guess the program or the mapping. Like if we have the context, I think it's enough. But we'll see. Man, it's gonna be so many errors. Let's just delete them and leave the formatting to the formatter. So here it's this guy. Okay, so this guy also expects the class index, but he doesn't even use it. Okay, so I think we should be fine there. class index is not used. Okay, here the class index is not gonna be used, I guess. Right, so we don't have it there. Then this guy. Class IDX. Okay, let's see. So this guy, man, I use it in so many places. But it's nice that we have the LSP so we can just go to the next error, basically. So yeah, let's see. Dude, how many how many are there? Dude, I swear. Isn't there a way to show how many errors I have? I guess I can do that to see how many I have. Hmm. Okay, so now I just have to remove the unused argument, basically. Okay, it was used here though, but the good thing is that we have context class, or I meant current class. Easy. It would have been really painful if it really was needed, like that would be next level of pain. You know, removing something and then having to add it back. Hopefully you use Git, my friend. Okay, I think those are all the errors. Can we do something like vim buffer? Not really. I guess to format the file we can do clang format. How can we use clang format? With the format. Does it have a right? I mean, I have a... Oh my god, I have a way to do it. Wait, what? That's really weird. Anyway, I guess I can also do clang format, but really they don't have a right. Yeah. Yeah, anyway. Let's see. Let's see if it still works first of all. So, oh no. I mean, we still have that to do stuff, but we have some random weird characters. What? So object inits. Okay, yeah. Object init. For this one, oh, parent mapping. Yeah, okay, I guess. It should have a parent though. Like, what do you mean? Yeah, like class object and stuff. But what the fuck is this? This is a pointer to it. Okay, I'll do like make and whatever. So there is like an address. Right. And it's the same for boolean and int. So I would say it's the object. But what the hell is this? Like, what's that scuffed shit there? So let's say I want to print the class parent name. Like, okay, what the hell was that? Class parent IO. I mean, that's interesting. Class parent object. Okay, so it is object init, and that works. But what the hell is this thing? Excuse me, what? Init attributes. So it comes in here and it shits the bed. What? So restore self is this, and it shits the bed here. So this is like the problem. Init attributes. Wait, what? Let's maybe delete this from here. Take this guy out. Let's go back to here and take the class mapping. Wait, class mapping item is the wrong kind of pointer, I think. Wait, class mapping item is the one with the attributes. Here I wanted the... oh, it's the parent mapping, yeah, it's fine. Let's do class B. Okay, and let's keep this one as class, right? Something like this. Let's see here, context, current class, and here is gonna be null. Class mapping item, and we take the current class. So like this, context program mapping. Okay. So let's see, printf class. Let's show the number of attributes or something. Attributes items count. Wait, what? Is a dynamic array. Okay, this is weird. Ah, it's a count. Okay. So it's gonna say boolean with one thing in it. Okay, I mean, it looks like this fixed it, but I have no idea how. And why is it this thing is twice? Why is it twice? This guy only has it once, and this guy has it twice. Like, what? Oh, I guess it's for each attribute, because it's an expression. Okay, yeah, fair enough. I have no idea how this fixed it though. I guess I probably I was using the wrong type somewhere and I didn't see it. Yeah, let's see. Okay, I still have that to-do statement, right? So that's what we need to fix now. Where's the to-do? So we can have class mapping item, class. Okay, I think the first one that we have to go through though is gonna be method. Isn't it a method mapping item? What? I thought it's oh, it's implementation. Yeah, like this. Current method is an implementation. Okay. So this guy is gonna have here the method node, so we can do if method is not equal to null, right? Method node pointer node, we take it's gonna be const. Sure, why not? Const node, and here we can look at the formals. So it's gonna be similar to this for loop. So it's for size ti is equal to 0, then node arrow formals.count. Let's see what this guy did. So formals. Oh, I haven't specified what it is. I guess formal node. That's strange though. I thought I had this thing. Anyway, I guess it's obvious what it contains, but nonetheless, it's good to have it. Okay, so we have the formals. We take the formal node. Okay. Yeah, I guess. Yeah, you know what? Method node pointer. Yeah, because this guy can take a const here. It makes sense, but I'm not gonna do that now. So we take the reference to a formal, and we have to compare the name, like the value, with the identifier. The same we do here. And if it's the same, then we take this guy, and we have to do 16 plus 8 times offset. Okay, perfect. That looks good. 16 plus, yeah, because we have RBP and the, I guess it's the frame pointer and the return address on the stack. But this should take care of the let's say the function call to do, right? So load message, it takes it from the stack, right? So that's good. And the other thing, okay, I guess let's check if it works first. So let's not use x here, let's put like 4 or something. So now if we do, we should do like what? We can put anything. It still prints stuff, right? And if we do 1, like it still takes the message from here, and that's good. So let's let actually the easiest next thing would be attributes, as I said. So x is gonna be equal to 4. The easiest next thing is the attributes. So attributes.count. We are always gonna be in a class, right? So that's we take this like this. So we take a class mapping attribute. So we have the name of the class, we don't care, and the list. Oh, the attribute node. Actually, we care. It's the name of the attribute. So we need to string compare it. So and here we don't even need to check if it's gonna be null or not, because we already did all of that checking in the front end of the compiler. So yeah, we should be good. So I said the name is a char pointer, so this should give us, let's say, the attribute, right? So now we get the offset, and the interesting question is how are we gonna use the offset? So let's say load identifier, and I guess if we take a look at the, like, I don't know, like string constant, it's a string object, so it has the type tag first, then it has the object size, and then the attributes. So we have to do the address of this plus 16 plus 8 times the index. So it's similar to this thing, but instead of doing RBP here, we need the address of the object. And yeah, I think that's, I think we might be fucked. I'm wondering how do we take the address of the object. Like, yeah, yeah, that's, oh, we have self. Yeah, we have self in RBX. Okay, we are saved. We are actually saved. Man, I remember that. Oof, that would have been like, that was a hard thinking problem. But okay, so we have self in RBX, and what that means is RBX is actually this address that I said, the start. So that's self. So we have to do RBX plus 16 plus 8. And I think this should just do it. We still have a 2 though. Oh, because I forgot to actually return this B. So if we go to hello world, so if we try to, okay, I mean, if we try to do any number like 1, it should say it's, well, I guess it is what it is. Let's see how it looks like in I guess let's see the init of the main. I'm curious. So it allocates one local, push RBX, move this. So it takes the int constant and it stores it here. Wait, what? I don't really like this. Because it doesn't actually initialize the... Like, what the hell? It doesn't really initialize. So here it does the thing for IO, but here allocate one local, because maybe it's gonna need it to do this thing. But then why does it store it like that? Oh, it stores it on the stack, then it loads it to work with it, and here it's missing something. So I'm curious why it didn't show the to do, because here is array x, or the A register, is equal to ident, and here is ident is equal to the A register. So it should try to do this thing and say that it failed. Right? So let's see again what I did in init. So here we initialize, here we init all the attributes. So here we init one attribute. So we should see. Okay, let's also check the tree address. Man, where is it? It's here. Oh, I forgot. I don't show the tree address code for attributes. So let's see a similar emit expression, and I did it for attribute value. But see here, I'm missing. Like I compute the expression, but I don't do anything with it. I think it looks like that, right? I don't do anything with it. So I compute the expression, I put it into rocks because it's low T0, but I don't do anything with it. So here I think we actually need to init assembler emit store variable. Okay, freaking unbelievable. So it's yeah, store variable. That's how it should be. Right, store variable, and it takes the identifier. Takes the identifier that it's gonna use it. Okay. So I guess we found another thing that we don't use. It's this. We actually use it. Mm, okay, that's strange. So this is for this one. I want to see for method, like an example of emit method. Formals, because for method we don't have to do anything. It's just emit expression. But for attribute we have to actually store it. See here it needs this result tree address code. It needs like the context of when it built the tree address code thing. But we don't have that because we don't even need it. We just know that what's in emit expression or what's in the A register needs to be stored in the attribute name. So maybe this should also be a pointer, right? And if it's gonna be null, then we skip it. So if tag is not equal to null, then we do this thing. But if it is null, then we cannot do it. So here we can pass in null. I mean, this can be a const. I don't think it matters. But I would do the same thing then here. Like this can be a pointer, just to make it symmetric. So if tag is not equal to null, we can do this thing. Otherwise we try the method. Right? And now again we should have some errors because we need to pass in the reference. Can I maybe have a macro that does this modification? Probably, but now I'm too far. I mean, I already imagined that I'm at the last 3 or 4 of them, so I'm not really gonna... Okay, perfect. So as I said, we have this init attribute, right? And we need to store it. We actually have to store it. So first, it's not gonna work. We are not... I mean, we can have a method, right? But it doesn't make any sense to store... But I mean, who knows? Maybe we can store stuff in the parameter, like in the function arguments. But that sounds so stupid. Okay, so I think we can actually use here ds panic unreachable. I don't think it's this code is reachable. So when you try to get an identifier, it's gonna try to get it from the... Actually, it is. It's gonna try to take it from the results, from the arguments, or from the current attributes, but it also can get it from, let's say, like let statements when it's gonna use x and stuff. So we also have to define those, but I think those are gonna be in a mapping, and they are gonna reference locals somehow. Or maybe I'm gonna try to change it somehow. Instead of using the variable names, to use the t0s. Yeah, that's something that we can think about, how to use the let statements like more easily, because I would put them in the... Okay, so this is store variable. So I said for method, I'm not sure what to do yet. Probably, I mean, I don't know if it works. We'll have to see if we can assign to there. Okay, so here we just need to do the other way around. Okay, and I think something's broken. Did I print? Oh no, it's this thing again. Like what? Okay, but here let's see. It still didn't work. What? Still not there. So main init. We load this row, but we don't do anything with it. What? Oh, I mean, yeah, it actually works. Oh, but here we do this thing, which I don't like. Actually, yeah, it's fine because we have it in array X, so it's good. Um, yeah, I think it actually looks fine, but I don't get why this thing keeps happening here. Like, here it calls to object init, but then why does that happen? Man, like, these pointers, I'm pretty sure it's like so many errors with them. So we try to initialize the init attributes. And it's fine because, like for example, string has one attribute, or boolean has one attribute, and also int. Like they have attributes. So interesting. But yeah, why is it a label though? Okay, so let's see what happens. So we try to init an attribute, right? So like, we try to do this thing, right? So let's print f. Let's print f the current class. Let's see. So it's class object, for example, in some of them. Right? Then it goes, does this, bam. Emit object init attribute. Wow. So I guess there's gonna be like probably a number of attributes here, right? It's gonna be like a number of attributes. So I'm curious to see the class and maybe the attribute then. Curious to also see that. Whoa, what? Why was it a segmentation fault? Okay. I mean, let's just run on this. attribute x, attribute val, attribute L. So stuff kind of works, but at the same time it doesn't. So let's try to also use val grind on this val grind, because it's probably gonna tell us what's wrong here. So 184. This depends on a what? An user an initialized value of size 8. But what can be uninitialized there? So I see it refers to this thing. So like attribute L. I guess I know. Maybe it's because we use that external thing, and here, so like when we did a parser, let's see, let's search for external. This is what the build attribute, right? So if we found like extern, we set the value type to null and the kind to extern. So here we pass in the value, which is gonna be like that. Right, so I think that's fine. I mean, these guys are useless anyway. So let's see, printf kind maybe like this. Let's see. Let's do make and let's try again. Kind 25. So I think that's like the last one, right? Am I right? So if we do 25 down, yeah, it's extern. So it's gonna be extern. And then here we do expression to tag, but I see that the error then comes in emit TAC. So the error comes here. Okay, let's see what happens if we do codegen.c. So what happens if we have... Whoa, I haven't used that. What happens if I have extern? I wanted to say, but I see that I don't have it. Case expr extern. Like I don't do anything. Tag instruction. if it's extern, yeah, so this should also match on the function. It's the method. So let me check. So for method, I took all of them. But I removed the extern. Okay, so if it's extern, then I skipped. So then the question is, what should I do for the attributes that are extern then? So like here, let's say attribute. Here's what value. Maybe here let's do a panic, like cannot generate yes panic. So like here, if we try to do an init on an extern, it shouldn't do anything, right? And I'm still thinking that maybe it should store 0 in it, but I'm not sure. I guess no, it shouldn't do anything because you cannot do anything on it, so it's fine like this. So I guess I missed this one when I did for the method, or maybe I did attribute first and then I missed it. Mm-hmm. But yeah, I guess it makes sense like this. And then for attributes, I said that it might be easier to just do that. Okay, so I guess this should remove that issue. Oh my god, it's so good to see. Oh no, it's still an error somewhere. Let's see. So here when we initialize main, so in 188 somewhere, 188 emit variable. So it says that, and then 467. Here, so it's in uninitialized, yeah. So if we go to object inits, emit object init, here let's also say that context current method is equal to null, just to have it initialized. Oh my god, it's so good that now we got rid of all the errors. Perfect. So I said that this should hello. So this should still work. Doesn't. Okay, why wouldn't it though? Um, wow, I'm a bit lost. Okay, so here, when we take these, I don't think it's possible to. Maybe do something like echo 1 into. Yeah. Not really. But I don't. Oh, I would have to. Oh, that's strange. I don't know how to do that. I guess let's look at the generated code. So I guess what we do for main, or at least let's see how we initialize the main init. So we allocate 1, store t0, load t0 into array x, and then we do rbx plus 16. So rbx plus 0 is the size, rbx plus 8 is the size, and rbx plus 0 is the tag. Right, and rbx plus 16 should be the variable. Okay, let's do something simpler. Let's out int. Let's out int x. Let's see how it looks like. Okay, so it says 4. It means that we actually find stuff from there, but something's wrong when we do like this thing. So let's see. New int, whatever. Wanted to see when it's gonna say load x, but I don't see any load. Okay, here, load x. So it actually knows where to find it. I mean, yeah, I have to GDB it, I have no choice. Start I, let's go. So let's breakpoint here, let's continue, and then let's go. So this one we can skip, I think it's reading stuff. So continue. There was some number. Here is creating the new int, so we can also skip that. Okay. Here is the division and stuff, so completely useless, I would say. Here is creating some other number. So let's go ahead. And I think this one is creating, or what? It should be creating the boolean, probably. I haven't, yeah, I did it right, okay. So, creating the boolean, so here we have rax, which should be like what, 100 divided by 10 minus 4, so it's 6. Yeah, that's good. We store it there, and then we do rbx plus 16. So rbx plus 16 should be self. But I see that rbx is referring to a tree. So why is that? Why is it referring to a tree and not a 5 or whatever the main class is? Or main object, I wanted to say. Why is it like an int? Really strange. Or I guess, yeah, I mean, I don't know. And obviously this is not gonna work, so it's gonna probably just die here. Yeah, okay, so I guess something's wrong with rbx, but I don't change it. So push rbx. rbx equals rax. Right, so rbx is gonna be the current self, and then I don't change it like anywhere. Let's see, so if I search for rbx comma, we have here, we have it here, and like everywhere where we change it, we push it and pop it, so it's not really gonna change, right? So I have no idea how it got changed. Start high. So here we go in the main function. So let's breakpoint this guy. Let's continue. So see, it's 5, right? So now we push it, we move that, and okay, let's say that we breakpoint here and we continue. So we read the number 100, but rbx changed. What the hell? Okay, rbx changed because of read integer. So let's go into prelude.asm and let's see where I did the inint. So inint pushes rbx. Okay, that's good. And at the end we pop rbx. So I don't see how it changes rbx. So I push rbp, move this guy, move this. Maybe did I use lock 5 anywhere? No. 5 times 8 is 40. Log 5 is, oh wow, yeah, great. Log 5, log 4 is 40, so I mean, maybe should I put 48? I don't know. Maybe int string broke something. So this also 5 variables. This is also push rbx. Then we do log 3, log 4. Log 4 is the maximum. So this guy still doesn't change. Maybe some of these. So equals doesn't do anything yet. Push. Push RBX. Pop RBX. Size off is fine. Malloc. Push. And then we pop it. That guy is fine. Mem copy. We push it. And then we pop. Parse int. So again we push it. We do two variables. And then we use log 0 and log 1. And here at the end we pop RBX and then we deallocate. We add 16. So I have no idea how it changes the. So like the only option is to actually go in that function. So let's continue and let's see. So we subtract that. We push RBX and let's see when it's gonna change. So how about skipping some of this stuff because I'm too lazy to actually look it. So if we step instruction, let's see what happens if we skip this guy. So let's breakpoint there and let's continue. Nothing. Okay, so wait, what? Okay, something I think I fucked it, so let's try again. Okay, let's go here, let's break this, let's continue, step. And yeah, I mean it's gonna take too much time to oh, it's the number, so it's like 100. Oh, but I said I wanted to see. Okay, let's start. I step a few times, breakpoint this guy, step into it, and this is a function that actually breaks. So let's see. So I want to keep an eye on RBX and also the top of the stack. They shouldn't change at all, or like at least when the RBX changes, like not really a big deal because we still have it on the stack. But I don't know what this function does, so let's skip it. Also, it's the reading of a string, I guess. So the reading of the string is fine. Okay, and this is the parsing of the string into an int. So let's see what happens there. So we continue, and it also looks fine. Right, the top of the stack is fine. RBX is fine. So here we subtract. Oh no! Oh my god! Oh my god! First I have to pop RBX, and then. And I like that even though we have like really small bugs, it still works some of the time, and that's the worst part. So input is greater than 4, obviously. I mean, let's actually do a real comparison because 1 less than 10 greater. So now we can actually use these things. So for example, x is going to be equal to int, right? And if x let's do something like x divided by 2 times 2 is, oh, we don't have equal. I guess less than x divided less than x, then it's gonna be odd. Input is odd, input is even. So now we have this really cool check if it's, whoa, what? Mm, oh, I guess make. Why doesn't it work? Wait, what? Oh, it was needed show message. Okay. So 1 is odd, 2 is even, 10 is even. So we have a even odd calculator. Pretty cool, not gonna lie. So yeah, I mean, I guess probably this should do it, I think. Maybe, I mean, we managed to... we still have to figure out this part. If we... like, can we actually do that? That's something that... like, hello.cl. That's something that we might have to check. Like, can we do... something like message is equal to that? Can we do that? We can. Can we actually do it? It feels a bit wrong to be able to, but I guess if there's no error, then it means that it's fine. I don't know. So let's see. We added these comments, so these are just docs. Let's do a fix. What? Okay, we fix the allocate after pop rbx. Okay, inside of CodeGen, just in case someone is crazy and tries something stupid, here we increase the context. We made the context contain the current class and current method, and I guess we fixed all of that crap. So yeah, I guess no, it's just doing the load and store for attributes. So feature load and store from attributes. Maybe assembler. Let's see. Maybe one extra thing that I can do. It should be pretty easy to do. Is wait, what? Is and I have a brain freeze. So if we try to get the identifier, if we try to store it, so I wanted to just copy paste this thing. Put it here and say store. This should also be store. And it should go the other way around, like this. So now we can store in the arguments. so it's fine. I mean, let's also test it. If we go to hello.cl, yeah, let's see. I mean, this won't work because we don't have the function, but we can do something like this, and regardless of the input, it should always print hello world. So yeah, can we have that? Yeah, input is even. Okay, perfect. So now I also have, well, I mean, let's do this. So now we actually did that. So I guess this should do it. We still have to be able to, I mean, I'll just put here the to do the let variables. I'm not really sure yet how I want to approach that. And I mean, the last thing is to implement, I mean, new operator, we already have it. I just have to put it here. Is void is gonna be just a check if zero, and then this is for the case instruction, for the case statement. And obviously the EQ, we have to implement that. It's gonna be a bit more tricky. But yeah, I guess like maybe 4 or 5 more days and we should have the complete compiler, or at least some version that will work for 99% of the cases or something like that. But yeah, like only the let statements, that's what I'm not sure about. Maybe I want to not use the variable names and just use t0 for like you saw there. For example, let's take a look at tree address code tests. Tree address code, and let's do one with let. Do we have let? Yeah. So here we do z equals t0, but how about not doing this instruction, and instead of z everywhere we use t0. So here we put t0. Yeah, like instead of using the z, we do t0 for it. I mean, I think that should work. But yeah, I mean, the thing, yeah, it's pretty cool. So yeah,